Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll take a look at another type of motion problem, this one involving a current. We see this when we're talking about a river, like in this problem that flows at a certain rate downstream, but we could also look at it in problems where we're flying into the wind or with a tailwind, same sort of concept. Couple of main ideas here. First, we're going to continue to use rate times time equals distance. And the rate with these currents, we need to figure out how that works. So with the current, it's your speed plus c, the speed of the current, because the current is pushing you, it's adding to your speed. When you're going against the current, we subtract c from that speed because it's working against you. You're trying to go against the current, it's pushing you back while you're pushing forward. Right. Let's read the problem and then we'll set it up. Lucy took her canoe to a river that flows downstream at a rate of 2 miles per hour. So that's the current of the river, 2 miles per hour. She paddled upstream for 2 hours, then turned around and paddled downstream to return to her starting point. If the return trip took 1 hour and the total distance covered was 16 miles, what is Lucy's canoe speed in still water? Okay. So there's two legs to this trip. There's downstream, that's going with the current. Oh, I'm sorry, upstream was first. Let me write it this way. We'll put upstream first. That was the first leg. Downstream was the second leg. And for each, we're going to have rate, time, and distance. Looking at the second sentence, she paddled upstream for 2 hours. So her time upstream was 2 hours. And then she turned around and paddled downstream to her starting point. That return trip took her 1 hour. So we know 2 hours upstream, 1 hour downstream. The rate is going to be the rate of her canoe in still water and then affected by the current of 2 miles per hour. So upstream, that's going to be x minus 2, and downstream will be x plus 2. Now we can distribute, right, multiply across rate times time equals distance. 2 times x minus 2 is the distance traveled upstream. 1 times x plus 2 is the distance traveled downstream. And we know that the total distance was 16. So let's start there, and then we'll take a look at another way we could have solved this equation, or another equation we could have solved. 2 times x minus 2 plus 1 times x plus 2 is equal to 16. Distribute. 2 times x minus 2 is 2x minus 4, plus 1 times x plus 2, that's simply x plus 2, that equals 16. Combine like terms on the left, 2x plus x is 3x. Negative 4 plus 2, that's minus 2, that equals 16. Add 2 to both sides of the equation to isolate the variable term. We have 3x equals 18, divide by 3, and we end up with x equals 6. Now, before we go back and figure out what we needed to come up with, there was another equation we could have used. The 16 is actually kind of extra information here because Lucy returned to the same point. That means that the distance traveled upstream is the same as the distance traveled downstream. And so instead, we could have used 2 times x minus 2 equals 1 times x plus 2. Distribute. 2x minus 4 equals x plus 2. Combine all the variables on the left-hand side by subtracting x from each side. X minus 4 equals 2. Add the 4 to both sides, and we end up again with x equals 6. So we could have got the same solution using a different equation. The 16 actually wasn't necessary here. All right, what are we asked for? We're simply asked for Lucy's canoe speed in still water, that is x. So her speed in still water is 6 miles per hour.